Hello! In this video, we are going to prove the following theorem. Suppose A, B, and C are sets. If A and C is a subset of B and C, and A or C is a subset of B or C, then A is a subset of B. So let's start out by supposing that A, B, and C are sets. And now, we want to prove if these two things are true, then this must be true. So let's assume that this and this are true. And now our whole goal is to prove that A is a subset of B. That is, we want to show that everything in A is also in B. And to do that, give me an arbitrary element of A. I'll call it X. Okay, so then how do we plan on showing that X also lies in B? Well, we can't use this fact unless we know that X is also in C. And we could use this fact, because since X is an element of A, clearly X is an element of A or C. So it follows that X is an element of B or C, but since X is an element of B or C, we can't be sure that X must be an element of B, because it could be an element of C. So it seems that the set C is the thing that's giving us problems, right? We're not sure whether or not X is an element of C. But we know that either X is an element of C or X is not an element of C. So what we could do is we could prove that in either case, X must be an element of B. So let's consider two cases. Either X is an element of C or X is not an element of C. In either case, we're going to show that X must be an element of B. Let's start with case 1 where X is an element of C. Now notice, we have that. Now notice, in the case where X is an element of C, we know that X is an element of A and X is an element of C. So really, X is an element of A and C. But then, since A and C is a subset of B and C, this means that since X is an element of A and C, X must also be an element of B and C. And of course, since X is an element of B and C, we have that X is an element of B. So this completes the case where X is an element of C. Now let's consider the case where X is not an element of C. Okay, so what can we do if X is not an element of C? Well, let's use the fact that we haven't used yet, which is that A or C is a subset of B or C, right? Since X is an element of A, clearly X is an element of A or C. And since A or C is a subset of B or C, and X is an element of A or C, it follows that X must also be an element of B or C. Okay, now, because X is an element of B or C, this means that either X is an element of B or X is an element of C. We have that either X is an element of B or X is an element of C. However, since X is not an element of C, that eliminates this possibility. So we must have that X is an element of B. And so that completes case 2. So we've shown in either case, we must have that X is an element of B. Therefore, X is an element of B. So putting this together, we start with an arbitrary element, X, in A. And we show that X is also an element of B. Therefore, everything in A is also in B. And so this completes the proof. And so yeah, that's pretty much the idea of how you could prove a theorem like this. So yeah, that's pretty much it for this video.